problem 7 now. We have transmitting a normalized square wave. So what does that mean? Well, depending on how you define your square wave, if we've normalized it, we've made it so that the positive peak is at +1 and the negative peak is at -1. So we're going to transmit this with on-off keying. On-off keying is a special case of AM with a modulation index of 1. So basically what happens is we take this square wave, multiply it by 1, in other words, we don't do anything, then we shift it up. So we add 1 to it to make it go between 2 and 0. Then we multiply that by our carrier so that we get a carrier that's on, then it's off, then it's on, then it's off. So this is asking about the power used for the message as a percentage of the total power. So one of the things we can use is that equation for efficiency, which said that the efficiency, which is how much power as a percentage is used for the message, is A, which is our modulation index squared, and then we have the mean squared of our normalized message all over 1 plus, and again A squared, the mean squared of our message. So the tricky part of this problem is, what is the mean squared of this? So the problems up to this point, it was just that the message was a sine, and we knew that the mean squared would be 1/2. But what is the mean squared of this normalized square wave? Well, we square it and then we take the average. So if I square this square wave, 1 squared is just 1. Then -1 squared is also 1. Then 1 squared is 1, -1 squared is 1. So this thing squared is just 1, then the mean of 1, the average value of 1 is just 1. So this whole thing then simplifies to a squared over 1 plus a squared, and we're told that a equals 1. So this whole thing simplifies to 1 over 1 plus 1, which is 1/2. So for on-off keying, half of the power is being used for the carrier, half of the power is being used for the message or those sidebands. So the answer is B.